Alright, well, welcome to Computer Science with Mr. Goddard. So today we're talking about hardware, software, and the parts of a computer. If you open up the box and you see all the stuff inside, we're going to be kind of talking about what are those different pieces, what do they do, and just really skimming the surface here. I mean, you could have hours and hours and courses and discussions. We're just going to try to hit the highlights here. So essentially, everything dealing with the computer is either hardware or software. Hardware is hard. It's the physical, tangible parts of a computer, the stuff that you can touch. If you open up the casing and all the stuff that you see there, the things outside of it, that's all the hardware. So the keyboard, monitor, hard drive, graphics card, fan, all that, the motherboard, the processor, all that stuff is hardware. Software is soft. Well, you can't touch it. This is your programs, this is your data, this is your operating system, your applications, all the things that run on the computer, so to speak. In order for a computer to work, you've got to have both, hardware and software, and each one's pretty much useless without the other. So, inside the box, the main brain of your computer is something called the central processing unit. Everything that your computer thinks, all of the processing, all of the thinking, everything goes through there. So for instance, you type something with a keyboard, it's going to go through the central processing unit, it's going to figure out what's going on, what keys you're typing, and it's going to then send a message out to the monitor. Maybe you type something in or do some mouse clicks, I guess that would be another arrow over here. It might send some information to the RAM, which is your main memory. It's sort of like it's short-term memory, like what it's thinking about right now. And then there may send things back and forth between that and the hard disk, which would be its long-term memory. And we'll talk about these more throughout the year and in other different sessions. Also, maybe you've got an optical disk, like a CD or a DVD. That's going to interact with RAM. Everything's got to go through central processing unit, though, the CPU, as we call it. So here's that same kind of picture, but with some other labels. We've got storage. You can see the chip, the main processor, and we also have some other categories, input and output. So your input devices are obviously places where you're getting data from, your keyboard, your mouse, other devices. Your storage could be your flash memory, like your USB thumb drives or flash drives or whatever you want to call it, your hard disk, which actually is a disk. And then your output could be your printer, your screen, your speakers, all kinds of other stuff. This is a picture of a motherboard. What is inside the big board right there, it's called the motherboard, where everything is sits on or sits inside or against. Let's see if we can find the CPU. The CPU is going to sit right there. It's the biggest chip. It's the most expensive piece normally of what is inside because it's the most important. All the information has to go through that. And because all the information in the form of everything in the form of electricity is going through that, this gets really, really hot. And so that's why you have something called a heat sink, which is going to sink away, drain away the heat, and then normally there's a fan to cool that off and to blow all that heat away. This is a picture of a memory stick. Memory comes in a lot of different forms and fashions nowadays. This is one of those short-term memory sticks. You've got the power supply, which we plugged in over here. This is what's going to give power to everything. All these different things require power, and this is going to adjust the voltage and the current that each component, each part requires. Maybe you got a DVD burner that'll plug in right there. Your hard drive, your long-term memory. That's like your C drive on most of your Windows computers. Your video card, little typo there, video card. Sometimes you have a video card there. Sometimes that is actually placed, the video card processing. Sometimes it's actually in the CPU as a little section of it. So this is an analogy that I've found that's kind of helpful, but of course, like all analogies, it breaks down at some point. It also depends on how well you understand how a restaurant works. So let's see if we can work through this. So let's say you've got a really, really fancy restaurant with all sorts of stuff. So we're not talking just a regular mom and pop shop or just like a fast food. We're talking about something that's very elegant, lots of cooks, lots of chefs, fancy menu, all the works here, right? So the restaurant's a physical place, physical location, has all the rules of the business. That's the computer. You've got your hardware and how those pieces interact with the software. All right? Then you have maybe the waiter. He takes your order. He's the guy that you interact with. Well, with computers, that would take the computer part that would fill that role would be an application, like your Microsoft Office or Chrome or Internet Explorer or any Windows Media Player or Adobe or Photoshop or anything that you're interacting with the mouse. Right now I'm using my browser and I'm interacting with a program on that, to another program to record this. So that's who you're talking to. That's who you're interacting with. What your order is, what you want to eat from that restaurant. Say, I want this or I want that. Well, that would correspond to your input, your mouse clicks, your keyboard presses and keystrokes. If you have a microphone, if you have a webcam, that's your input. Kind of matches your order. The kitchen in the restaurant, that's where the magic happens. That's where your order goes in, it gets processed, your food is retrieved and gathered, whatever is prepared, cooked, chopped, mixed together. Who knows? Everything is done inside the kitchen. That's where we're talking about. That's like what the motherboard does. Your input is processed, more data is retrieved, things sent back and forth, chopped up, calculated, and then the results are then sent back to you, the user. Now, in any kitchen, a good kitchen, there's going to be recipes, and there's going to be rules of the kitchen, such as all employees must wash their hands thoroughly before leaving the restroom. That's a really good rule. There's also rules about cooking and how you're going to cook and how you're going to, what temperature this needs to be at, or how much you need to cut up this vegetable, or who knows what it is. So you've got your rules and instructions that have been set in place for how to make the food and how the cooks and assistants work together. This is going to make, if you get this certain order, you're going to have this part being cooked first, and meanwhile this is going to be prepared, and the idea is everything wants to get ready at the same time. That, on a computer, those internal rules is governed by something called the firmware, or ROM. These are the instructions. They can't be modified, can't be changed by the user, and they determine how all the different pieces talk to each other and how all those rules are set up. In fact, when you first turn the computer on, the ROM is what gets executed. The head chef. He's the person who reads the order. Now, like I said, this is a fancy restaurant here. And then he assigns different tasks to the cooks. So we've got a restaurant here. If you look down here, you've got all kinds of different cooks working all at the same time. Well, somebody's in charge of all of them, and it's the head chef. He's going to tell them what to do, how to do it, all those. He may not even cook. He may just walk around and do a little taste testing and stuff like that. But he's giving all the instructions and telling who to do what. That's your CPU, your central processing unit we saw there at the very beginning. This chip accepts all the input, assigns the tasks to this processor, this core. Actually, there's even different parts inside the processor, the CPU itself, that it assigns stuff. Sometimes it assigns something over here to get calculated or whatever to another chip or whatever. So that's how those relate. The cooks are the individual people who take those instructions, mix the food, yada yada yada. Like I said, if you were to look inside this CPU, you could actually see what are called cores, different processors just themselves, which can do multiple tasks, and they can even do them all at the same time. And you get something called parallel processing. It speeds things up a whole lot rather than just having one core. Just like if you're having a bunch of different cooks. Hey, you work on the vegetables. Hey, you work on the fruit. You over here, you work on the soup. You work on the meat. Everybody's doing something different, and that's the same thing you can do. You can separate the task into different cores. Now, at each one of those cooks, they've got food at their station. If you see here, he's got some flavors and some seasonings. He's got some other stuff like that. He's got his oven or stove and things going on there. So you've got food items that are frequently used, readily available for speedy access. So they've got stuff right there, like maybe the salt, maybe the pepper, maybe the cilantro, I think how you say it. Anyway, so that stuff, that food that you need right away, maybe some bits of parsley to sprinkle on the food if it's a really fancy restaurant. on the computer, that corresponds to the cache. See all those different cores, sometimes they're placed in a different place, like over here. They need some fast access to data, and that data that's really closely shared and really easily accessible is called cache. Now, some of the information you don't need as quickly. Sorry about that. And that is like the food in the fridge. Okay, you need it, but not often enough that you want it sitting out because it might go bad. So especially if and so you want to keep it refrigerated. Well, so it's short-term food. Well, that's like RAM. So short-term memory. So data instructions that are used frequently, but they're not used enough to be put into cache. Maybe they're just too large to be put into cache. And when the power goes out, then this data is lost. Just like when the power goes out, the food in the fridge goes bad. Now we'll go here. So this is a real fancy restaurant, by the way. In the back, they've got the warehouse. There's a whole warehouse attached to this restaurant. And they have long-term storage for food that isn't needed frequently. Maybe also some plasticware, paperware, napkins, who knows what else. So food is brought from that warehouse to the fridge or to the cook's table whenever that happens. So the warehouse is like your hard drive. This is long-term storage. It's always going to stay there. If the power's cut, that's okay. And then things are pulled from here as needed to go to the RAM or to the cache. So you might have a food delivery truck that's going to carry, the food delivery truck is going to bring some food that, this is like your daily special. Maybe, we get some food from like a farmer's market. You get something real fresh, or you get something from I don't know, the docks or whatever. I don't know, if you're way inland, maybe you don't have access to shrimp or to salmon really quick, so you got to get that stuff from the food delivery truck. So something that's it's different from day to day. It's a little bit slower than the cook's table or the fridge, but you've got special access. That's kind of like your optical disc, like your CV or DVD. It's not on your hard drive, and it's definitely too big to be stored in RAM or cache, and it can change from time to time. So it's kind of I feel like a good analogy at that. So then you've got, in this fancy restaurant, cooks, assistants, and food runners. These are the people who get the food, get the utensils from the cooks, and they are running it out to your table. They're not taking your order. They're just delivering the finished product, and they make sure it's all set. And these are the people that say, "Watch out, it's hot," and then you never see them again. In the computing world, that would be like something called a bus, and then the output device. The bus are the wires that carry the data from one unit to another, like from the RAM to the cache, and then we'll carry that information from the CPU all the way out to the monitor or to the speakers. So that's the final preparation, the final thing that goes there. And, in a good kitchen, there's going to be a clock, probably a whole bunch of clocks, to make sure that everybody's, aware when things are happening. If you've got a potato that's going to cook for a couple minutes and some steak and some other things, you want everything to be ready all at the same time. Everybody's looking at the clock, counting down, making sure that all the food will be ready and is coordinated. There is a clock. It's called the internal clock inside your computer, where it sends a pulse. And it's going to send a pulse, several million or billion times a second to every different part of the computer to make sure that they all are talking to each other at the same time. They all say, "Okay, ready, share your information now, and now, and now." So sort of like your metronome in band, your steady beat. So there you go. That's that is a super fast look at the hardware, the software, and different parts of the computer. Hopefully that restaurant analogy didn't confuse you. If it did, I apologize. Thanks for watching.